Hello, welcome to this LinkedIn Live session with Teradata. My name is Brian Wood. I'm Director and Cloud Advocate, and I'm also joined by my colleague Mark Shainman, Director and Analytics Advocate. Between the two of us, in the next half hour, we're going to talk about boosting your flexibility and slashing costs with native object store. Basically getting more value from your data in Amazon S3, Azure Blob, and Google Cloud Storage. So I'm going to go first, and then I'll hand off to Mark, and then we'll take your questions. So let's talk first, real briefly, who is Teradata, in case you don't know. We're a cloud-first analytics software company. We focus on enterprises globally, kind of the largest of the large industry leaders. We're nearly 100% subscription. This is a big change from the past where we were a little bit more hardware-centric. We're very much focused on analytics software now. We have scale, nearly $2 billion company, over 9,000 employees. And we've been at this, the data and analytics software and consulting business, for over 40 years. We love the cloud because we're a software company, right? We want to deploy on global infrastructure, and rather than companies deploying in their own data centers, obviously the major trend is to deploy in the public cloud. So we have invested very heavily. We've got employees, hundreds of employees with cloud certification, thousands with accreditations, and we've literally spent millions of dollars to optimize our software for public cloud deployment. Our new CEO, been on board for a couple months, very much focused on the cloud, hybrid cloud. So let's look at Teradata Vantage. This is the name of our flagship software. Vantage, it's the new name for what used to be called Teradata Database. This allows customers to use any analytics tool, any language, on 100% of their data. And by tool, I mean all the typical industry things like ETL tools, visualization, BI, DI. So all the big names that you know and love for doing analytics now can all be used with Teradata Vantage. Any language, I'm talking not just SQL, which is the main language for business analytics, but also languages like R and Python and SAS and Java. And then 100% of the data, and that's really what we're talking about today. So not just data in the database itself, which uses block storage, but also data in other repositories. And specifically today, we're talking about object storage. And I have a slide describing the difference between those. So any tool, any language, 100% of the data for the best analytics. We deploy our software in 3 different public cloud providers: AWS, Microsoft Azure, and Google Cloud Storage. We started with AWS in 2016, and then we added Microsoft Azure in 2017. And I'm proud to say this year we're adding a Google Cloud Platform. So we have the big 3 for most of the world. It's the same Vantage software everywhere. This is a big differentiator for our customers, many of which are coming from on-premises environments into the public cloud. And so to make the migrations easier, quicker, and lower risk, we have the same software everywhere. So there's no recoding or retraining or reprocess engineering, exact same software. So you can leverage existing investments, and it doesn't have to be either or. You can have a hybrid environment on premises and cloud, which more and more is what customers are doing. They're either hybrid on-prem to cloud or multi-cloud. With Teradata, it's easy because it's the same everywhere, and the licenses are portable between these environments. If we looked at our as-a-service subscriptions, our cloud subscriptions, they're very comprehensive. So all the capabilities there on the right, we provision the infrastructure, of course the software, we manage the environment, so that's security monitoring, the encryption, daily backups, all that good stuff. One thing that's very unique about Teradata in the cloud is that our subscriptions are single tenant, and by that I mean each customer is deployed in their own account or subscription. So in the AWS or Google world, it's called a VPC, Virtual Private Cloud. In the Azure world, it's an account or subscription. Each customer is in their own, so there's no sharing. So there's no sharing of the database with other customers. There's no sharing of the underlying infrastructure, the compute and storage resources. So even though the public cloud is inherently a multi-tenant environment, Teradata deploys in such a way that each customer is isolated from the other. So that means higher security and higher performance, and none of that noisy neighbor syndrome that can be a detriment if you're in a multi-tenant type environment. If I go now to look at what we call the console, this is the environment that customers use to scale their Vantage software in the cloud. And scalability, elasticity, this is an expected feature of any software in the cloud, and of course Teradata supports it. So we're talking about vertical scaling, the size of instances, horizontal scaling, the number of instances, as well as stopping the compute from running, like stopping the meter independent of storage, and then restarting it when need be, and then of course expanding storage. So talking about storage, I mentioned there are two main types of storage in the public cloud. There's block storage and there's object storage. Block storage is typically used for high performance databases like Vantage. It's higher priced and it's higher performance. So typically the type of data in block storage would be your structured data, your relational data. Names of object or block storage in the public cloud: Amazon EBS, Microsoft Azure Premium Storage, and Google Persistent Disk. So those are block storage. Object storage, much lower price point and very flexible, typically used for lower or unknown value data. So this could be, it could be relational data, but it also could be unstructured data. So things like web files or web click streams or sensor data or images or videos, things that don't normally go into a database. And a much lower price point, some, about of order of magnitude lower price. And names of these object stores, very familiar to most of us: Amazon S3, Azure Blob, and Google Cloud Storage. So what we're talking about in this session here is querying data, getting value out of data in object storage. It used to be that customers would have to move data into the database or into a specific platform to do a particular type of analytic. And so data scientists and business analysts spend a lot of time moving data around, or because that's painful and timely and chews up productivity, sometimes they just use a subset of data to do those analytics, which if you're only using a little bit of data, you're not getting nearly as good an analytic result as if you're using all your data. So we encourage customers to use all your data, and it doesn't matter if it's in the block storage, the database itself, or whether it's an object storage or even other repositories like Hadoop or Oracle. But today we're really talking about getting value out of object storage. What we call this is native object store, and the whole idea here is one query, all the data. So after you connect to an object storage bucket or file or container, and Mark's going to talk more specifically about that, from there on, you don't even have to think about where the data is. And that's the beauty of this, is you don't have to remember where all the data is located and then write code specific to that. You just query the data as if it's all in the same thing, and Vantage is smart enough to figure out where that data is and do what's necessary to join with and query that data. And so it's simple SQL statement or R Python to go do that. Everything we're talking about here, native object store, is part of our first-party integrations. I'm going to show you 3 slides. The first one is showing our AWS integrations. So of course we integrate with EBS and S3, but also things like Kinesis and Lambda and many others as shown there. The next slide shows our Azure integrations. Same deal, not just premium storage and Azure Blob, but things like event hubs and streams and machine learning and you name it. And then likewise with Google Cloud Platform, the Persistent Disk and Google Cloud Storage, but many others, PubSub, Function, Dataproc, you name it. So heavy investment in integration with cloud first-party services, because we want you to be able to take maximum advantage of all the innovation going on in the public cloud. All right, so with that kind of setup, I'm going to hand things off now to Mark, and he's going to tell you more specifically about native object store. Mark, over to you.
Thanks, Brian. So when we headed down this route of our native object store technology, what I did initially is I interacted with a lot of companies out there. And I realized that a lot of them were really struggling with really the rising costs and complexities of analyzing data at scale, especially within their big data environments. Their existing environments were extremely complex. One of the key components was they were extremely difficult to manage. There was limited skill sets that were there in the marketplace to actually help them with these big data projects. And they cost a ton of money. And they also were really limited in analytical scale. So when we went down this path of putting together our native object store technology, one of the goals was to really eliminate a lot of the problems that customers were facing around their big data environments and really analyzing data at scale. So when we look at our Teradata Vantage 2.0 with native object store technology, one of the key components of it is, as Brian mentioned, we really wanted to take a lot of the complexity away from the administrator and end user. We wanted to enable the end user to use all the languages that they were used to, and that being able to access those data sets that exist within object stores. And we really wanted it to be a seamless data user experience. So they're not having to write proprietary code to access that data. They're not having to write this and load the data into the Teradata Vantage system before they're able to analyze it. They're able to analyze it in real time, leveraging their existing tool sets. They can run queries and joins across both that structured data that exists within columns and tables within their existing Teradata Vantage system, as well as Brian mentioned, some of that semi-structured data that exists within object stores, such as clickstream data or weblog data. You know, it could be in JSON format, Parquet format, or CSV format. And our native object store technology is able to dynamically access that data and then leverage the power of the Teradata Vantage database system to analyze that data. So let's jump a little farther in and look at specifically at native object store. Really the ability to seamlessly access the data that exists within these cloud object stores, the AWS S3, Microsoft Azure Blob, or the Google storage as well. So one of the key components when we developed this technology is we knew that we had existing users, or users that were used to existing tool sets, your existing business analyst or your existing citizen data scientist. So they have existing tool sets, such as their workbenches, their BI tools, and their languages, such as SQL, and as Brian mentioned, R or Python. So one of the key components of creating this technology is to enable them to use those tools that they existingly use and make it seamless to access that data that exists within an object store. So, and as an end user, all they have to do is simply write a SQL query, use their existing BI tool that executes SQL, write some R or Python, and they're accessing that data that exists within an object store just as it would be data that's locally, would be held locally within tables within the Teradata Vantage system. It's as easy and seamless as that. I'm writing a query to a table, and by chance, that table or that foreign table definition maps to data that exists within that object store. So now let's kind of dig under the covers and specifically look at how the native object store feature works. You know, how does this work? How do we create this seamless access to this data that exists within these cloud object stores? So what we have actually done is we haven't created another piece of technology that needs to be loaded up. We have integrated our native object store technology as a key component of the Teradata Vantage Advanced SQL engine. It is integrated into the engine itself. So all the components that are great within the Advanced SQL engine, such as the scalability and parallelism, are part of that Teradata Vantage native object store technology. So what an administrator would simply do is create a foreign table definition. And all this foreign table definition does is point to a bucket, or which is basically a storage container that exists within one of the public cloud object stores, Azure Blob, Google Storage, etc. An end user, as I mentioned earlier, would simply execute a query against this foreign table definition. Teradata Vantage Advanced SQL Engine reaches out to this public cloud storage and then does any type of filtering. It can actually do path filtering, eliminating some of the specific files or data that's coming in, brings that in to the Teradata Vantage system, uncompresses it, decrypts, transforms the data, does data type conversion, etc., and then all the functionality and all the analytic functions that any type of data that can be analyzed within a Teradata Vantage system can now be leveraged on that data. So to an end user, all they're doing is writing a query, and it's accessing that data under the covers. It grabs that data, uncompresses it, puts it into spool, and then runs the analytic process on that specific data. After that result set is finished, that data is flushed from the system. So it's just the same as accessing a local table and running a query. You're accessing this foreign table, this foreign data that exists within a public cloud object store, such as Amazon S3, Azure Blob, etc. So to the end user, it's seamless. But one of the great things about it is because it's leveraging that parallelism and power of the Teradata Vantage system, a user can leverage all that advanced analytical functionality now on that data that exists within an object store. So it really enables end users, when we look at the specific capabilities, to really natively read the data where it lives for ad hoc exploration. And that's one of the key components, which is awesome about the native object store technology, is that, as Brian mentioned earlier, to actually be able to access that data, bring that data in, an end user doesn't have to run an ETL process, load it into a table, and then run their queries. They dynamically just write a query or use their BI tool and access that data and run that analytic on that data. And one of the great things about it is a lot of users have existing data that exists within their existing analytical environment, the Teradata Vantage environment. And just by writing a query, they can dynamically join data that lives within that object store with data that lives within their Teradata Vantage system. Within a single SQL query, boom, they can access that data and enable them to get business insight dynamically between those two data sets. And also, I'll go in later, there are some great use cases for doing queryable archive and offloading of relational data as well, and really simplified loading. So think of it in this way. If I have data that exists within that object store, and I actually want to persist it within my Teradata Vantage system, all I do is write a query that queries that data and then do an insert select into an existing table. As easy as that. No ETL process that needs to be set up. No load utility needs to be set up. Simply write a query that queries that data and then does an insert select into a table. And I have just done a load process from an object store into the Teradata Vantage system. So now let's look specifically at some of the business use case scenarios. So there are numerous use cases for this technology, but three of the main ones that we see this technology being used for are really data lake exploration, queryable archive, as well as data sharing because of the ability to leverage these common formats such as Parquet, CSV, etc. So now let's dive into the first one, which is data lakes. So what I've really seen in the industry as a whole is organizations are shifting from their legacy Hadoop environments and looking for cheaper alternatives to Hadoop when it comes to their data lakes. So we've seen a marginal shift in the industry of organizations kind of moving away from Hadoop and moving that data lake-centric data into object stores, such as Amazon S3 or Microsoft Azure. So we really see that coming about because organizations not only want the ability to leverage the low-cost storage of a data lake, of the object store for their data lake, but also because they want to modernize their overall data lake ecosystem. And one of the great things about being able to leverage Teradata Vantage with native object store technology is not only can the customer leverage that object store for low-cost storage, they can utilize the advanced analytical capabilities within Teradata Vantage to analyze that data lake-centric data, such as clickstream data, functions such as path analysis within Teradata Vantage, machine learning within Teradata Vantage can be leveraged. Those functions within the advanced SQL engine can be leveraged dynamically on that data that exists within an object store, within their data lake environment. So, but one of the great things about it is not only can they leverage that analytical functionality within the data that exists within an object store, that's their data lake centric data, there could be an existing data warehouse data that exists within their existing Teradata Vantage system. So you really see the lines blurring between the data lake and the data warehouse, and they're becoming a much more holistic analytical ecosystem where the storage mediums become different, but you can leverage that advanced analytical capabilities of Teradata Vantage for both type of workloads. So when it comes to native object store and data archiving, as Brian mentioned earlier, there's a big delta when it comes to the cost differentiation between traditional block storage and then object storage. So organizations traditionally have data that ages out over time. And in many cases in the past, they would maybe archive that off the tape. One of the advantages of having Teradata Vantage with native object store technologies is now instead of having to put that off the tape, they can put it off to cheap object storage. But the huge advantage of having it on cheap object storage with native object store is that data is instantaneously accessible when they actually need it. One of the key things that you can do within Teradata Vantage with native object store that accesses that data within those object stores is you can actually create a view. And what this view enables the end users to do is when they're actually accessing a table or that foreign table definition, to them, it just looks like another table that exists within their Teradata Vantage system. So they don't know that if that data is local or that data is in the object store. So that's a huge advantage for them. Instead of having to go through a process and move data when they actually have to access that archive data, they could simply query an archive table that looks like a local table, which reaches out and accesses that data. And the overall advantage is customers are now being able to leverage a storage medium that is extremely cheap and much cheaper than the block storage that they leveraged previously. So one of the third use cases is actually data sharing. So with being able to leverage the data that exists within an object store, the great thing about object stores is they have common file formats that organizations can leverage, such as open formats such as JSON, Parquet, and CSV. Teradata Vantage with native object store can access and read those formats, JSON, Parquet, and CSV. And it really becomes a sharing vehicle. So not only is a company able to access that data through the Teradata Vantage system and get the value and insight out of Teradata Vantage, it can be accessible through multiple company technologies. So you can load that data into the data warehouse and data labs, but you can also publish out to the object store using tools and actually not only give other departments or other technologies within the company access to that data, but also business partners, if you choose, can access that bucket and put that data into a common format that can be accessed and analyzed as well. So it really facilitates this data sharing architecture that enables organizations to leverage the object store as a mechanism to share data throughout their organization as well as with business partners. So we really think there's some huge advantages to organizations being able to leverage native object store technology and leverage those common formats. So now let's look at some specific key takeaways from this presentation. So when we really look at it, we really see that native object store enables businesses to make use of the data in their data warehouse and their data lake. As I mentioned earlier, we can really see that there's a breaking down of the barriers between their traditional data lake data and as well as the data warehouse data, where you can easily and dynamically join the data between those two architectures and mediums. It provides this enhanced flexibility with the separation of compute and storage, and of course, that huge advantage of being able to leverage that low-cost storage. And you really empower the end user because the end user can get answers within seconds or minutes. They don't have to actually go through an administrator to do ETL processes or load processes, they can just write a query and dynamically access all that data that exists within an object store. And also being able to consolidate data within an object store as well as in the Teradata Vantage system really removes the need for data replication and removes that cost and eliminates that problem that a lot of organizations face with data silo proliferation throughout their company. So now let's take some questions from the people out in the crowd.
All right, good job, Mark. So what I see here, some questions coming in. Thank you, keep them coming. I'll ask the first one to you or two, Mark. Is there an extra cost for a native object store, and what does it take to get started?
There's actually no extra cost for native object store. It is actually an integrated component of the Teradata Vantage 17.0 engine and part of Vantage 2.0. And so once a customer has Teradata Vantage 2.0 or upgrades their existing environment within the cloud to that 2.0 version, they get the native object store technology as part of the advanced SQL engine.
Nice, nice. I guess I'll take the next couple questions. Is NOS available, or Native Object Store, is it available for Vantage on AWS, Azure, and GCP or Google Cloud Platform? The answer is almost. Yes, it's available for Vantage on AWS and Azure. And when we go GA on Vantage on GCP, which is right about a month from now, then it will be available then. So customers will be able to join with and query data in Amazon S3, Azure Blob, and Google Cloud Storage. Another question is Native Object Store available for do-it-yourself software? For customers, when we come out with Vantage 2.0 for do-it-yourself software, then yes, it'll be available there for that. And just like with our as a service environment, no additional cost. It's just an inherent capability of Vantage. Another question here, Mark. How will the parallelism work for the data residing on the object store?
Well, of course, we actually reach out and bring the data in parallel across all the amps in the Teradata system into the actual Teradata Vantage system. And once the data is in spool within Teradata Vantage, it is just like any other data or tables within the system. So all the parallel units and amp units that execute on regular tables within a Teradata system execute on those that native object store data. So of course we read it in parallel. It actually reads it in a round robin fashion across all the amps within the system, pushes it into spool, and then executes in parallel with that whatever analytical functions that's being utilized.
Cool, thank you. Question on file formats. So maybe if you could reiterate, what are the available file formats currently supported by NOS? And then go ahead.
Oh, so we presently support, as I mentioned, the CSV, JSON, and Parquet file formats. And we are investigating expanding that to other ones such as work, etc. in time. But for right now, it's those three file formats.
Cool, thank you. Would NOS parallelism potentially help performance to work similar or better than TPT or Teradata Parallel Transporter?
They're different. So TPT, of course, is a load utility and basically does mass loads into the Teradata system and just lands the data. The big difference between NOS and TPT is just a load utility, where NOS is you're actually executing a dynamic query. So I'm actually executing a select star from employee table and running a query on that data. So I'm executing that query. It's doing an analytical function. TPT, in the sense, is really just doing a bulk load from a data source into a table. So they're really different in how they do it. I right off the top of my head, I don't know the performance delta between the two if you're just talking straight ingest performance, but I perceive it would be similar between the two.
Got it. Thanks. Question, how does Native Object Store get visibility or connectivity to any specific data object? So, how does the user connect to, or how does Vantage figure out what object
Right.
files are
Of course,
available?
there has to be, when the administrator is setting up the foreign table definition, they have to map it to a specific bucket and data that exists within that bucket. So they have to have insight into that. We do actually have a function that allows you to do exploration of data that exists within a function. Basically, it enables you to just kind of look at data that exists within a bucket and gives you a response back and saying, hey, what data exists there? So you can do that. But then, of course, for continued query access, you have to know what data is in that bucket, map the foreign table definition to that bucket, and then execute the queries against it.
Got it. Thank you. One common question that we get, or discussion topic with customers, is how does Native Object Store, how is it similar to or different than Query Grid, which we've had for a long time?
Right. So the way that Query Grid actually works, it is actually executing from processing engine to processing engine. So for example, when I'm accessing data that exists within a Hadoop environment, I'm executing a query that exists from Teradata Vantage. It is passing that query over to Hive or Spark or Presto, and then that engine is executing the query against whatever data store it is. So let's say Hadoop data, and then that engine is actually bringing doing some processing and bringing the data back in. With Native Object Store, it is actually an integrated component of the advanced SQL engine. So it's not from processing engine to processing engine. It is processing engine directly to storage. So with Native Object Store, you're actually executing a query. It's reaching out to the storage medium. It's doing some filtering at that storage medium and bringing the data directly back into Vantage, and all the processing is happening in the Teradata Vantage system. Unlike Query Grid, which is, of course, Query Grid enables you to go from server to processing engine to processing engine, as well as there's an added cost for the Query Grid software, and there's setup and administration in setting up that Query Grid software between those processing engines. So they're very different. One's integrated component. I'm just accessing data that exists in an object store, an object store storage medium. The other one is I'm connecting one processing engine to another processing engine.
Got it. Thank you. So just to underscore, no additional cost for Native Object Store. It's inherent in Vantage 2.0 and everything thereafter. There's no additional connectors or anything that customers need to subscribe to. You just literally point it to, connect to, whether it's S3 or Blob or soon Google Cloud Storage, and have at it. And you can use both Native Object Store and Query Grid. So you might, for example, connect Query Grid to a Hadoop environment or an Oracle environment or on-prem data store if you wanted, and you can use Native Object Store for cloud object stores. So cool. That seems to have exhausted our questions. Mark, any final comments, parting words?
I just think it's a great piece of technology, and I'm glad we're came out with it moving forward.
Absolutely. I'm excited about it as well. Again, stay tuned for the launch of Vantage on GCP, in which Native Object Store with GCS will be available coming in about a month. And we appreciate you tuning in. We've got additional LinkedIn Lives coming up soon, so be on the lookout for that. And have a great day.